To start with this new playlist on another chapter on combinatorics, let's talk about the pigeonhole principle. Before providing you the definition in a generalized one, we're talking about the pigeonhole principle. Let's try to establish the idea using this illustration. Say, for example, you have pigeons, okay? You have pigeons, and then these pigeons are going to a certain area. Say, for example, they're a structure that can contain them, okay? So it's probably birdhouse for pigeons. So we can say it's pigeon house. Now, if we have here number of a lot of pigeons, let's say something like that, and all of them are to move to the same nest, and we have here a lot of holes, okay, a lot of holes here. Say, for example, there are also holes here where all of these pigeons can come in and get inside. This is how the pigeonhole principle. Now, if we have here a number of pigeons, and then we have here a number of holes. So say, for example, we have pigeons, and these are your pigeonholes, or actually the holes for your nest, for your pigeons, okay? So it talks about some of them. Of course, we don't know random, because the pigeons will choose a random hole. We don't know that there is a mechanism that once a pigeon passes through a specific hole, then it will be closed. No. The concept here is randomly, some of these pigeons might enter the same hole. Some of these pigeons might enter one for each hole, or even one of these holes will not even contain any pigeon, or not be passed by any of those pigeons. Now, the idea here is that if we have n pigeonholes, okay, if the number of pigeonholes are expressed by a certain natural number n, what would be the accessibility for all of these pigeons? Or what is the relationship with the number of pigeons to the number of pigeonholes? At the same time, what are the possibility that each of these pigeonhole will contain one or no pigeons, or even more than one pigeons? So here is the concept for pigeonhole principle. We may not actually involve the exact pigeons and pigeonholes concept later on as we move forward to this chapter, but we are talking about the same concept, that there are pigeons that will occupy a certain area passing through n possibilities, or say n pigeonholes, and we'll be talking about the relationship of how many will pass them, or how many will not pass them, or how many needed pigeons or pigeonholes for a certain situation. So for the pigeonhole principle, it states like this: if n pigeonholes are occupied by n, okay? So we have here n plus 1 pigeons. Let's say that your number of pigeons is more than number of pigeonholes, in this case, more than exactly by 1. Okay, then at least one pigeonhole, okay, is occupied by more than one pigeon. What does this pigeonhole principle tells us? Now again, if the number of pigeons is more than one than the number of pigeonholes, looking into the perspective, say for example, we have 5 here, 5 pigeonholes, and we have 6 pigeons here as illustrated, then there is at least one of the 5 pigeonholes here where it is occupied by more than one pigeon. Let us say that each pigeon, the first 5 pigeons, this one here, except for this, will occupy each one of the one for each of the 5 pigeonholes. Then the remaining pigeon passing through any of those will support the statement that one of the pigeonhole will be occupied by more than one pigeon. That is on the case where one of the pigeons or each of the 5 pigeons will occupy each of the 5 pigeonholes. Now, there are also some instances. What if all of these 5 will pass through pigeonhole number 1? In short, the remaining pigeon will have to choose amongst 4 remaining pigeonholes. Then that means other pigeonholes are not occupied. But since the concept of pigeonholes talks about at least one of those is occupied more than one, those 5 already passes to this pigeonhole. That would mean it already accepts the principle that pigeonhole accepts more than one. Okay? This is only true if the number of pigeons is more than the number of pigeonholes. Now, we will be illustrating some examples to this. Probably not any more pigeons and pigeonholes, but the concept that in the pigeonhole principle, if you have n plus 1, meaning you have more than your pigeonholes, or in short, these are your placement, and these are your objects. If you have more objects than your placement, then according to the pigeonhole principle, at least one of those placement will contain or will be occupied by more than one pigeon. It could be all, or it could be just more than one. It doesn't matter if some of those placement will not occupy any object, but the point here is at least one of those will be occupied by more than one pigeons. Again, we will have an illustration for this in the next few videos talking about this principle and its generalized principle later as we look into the other concepts related to this. Thank you very much for watching.